Hello everyone, welcome to my YouTube channel Physics with Pavitra. In this video, we are going to try and solve few of the previous year questions from various competitive examinations on the topic Coulomb's law. So the first question says that if two charges Q1 and Q2 are separated with distance d and placed in a medium of dielectric constant K, what will be the equivalent distance between the charges in air for the same electrostatic force? So, from reading the question, we understand that there are actually two cases. So, the first one is in a medium with a dielectric constant K. So, we are having two charges Q1 and Q2, which is separated by a distance d apart from each other. And this medium, as stated, is in a medium whose dielectric constant is K. Now, for this case, the force which is acting between the two charges will be 1 by 4 pi epsilon naught K Q1 Q2 by d square. Now in case 2, which is in air, we have the same two charges Q1 and Q2. The condition given here is that the force which is acting between the two charges is same in both the medium and in air. So if that is the case, we need to find what is the distance between these two charges in air. So they are stating that the force in case 2 and case 1 are going to be equal. So the force in case 2 can be written as 1 by 4 pi epsilon naught Q1 Q2 by x square, right? Now equating these two forces, we will have 1 by 4 pi epsilon naught K Q1 Q2 by d square, which is going to be equal to 1 by 4 pi epsilon naught Q1 Q2 by x square. So by simplifying this, we will have 1 by kd square to be equal to 1 by x square. So my x will be root k into d. So this will be the distance between the two charges when placed in air to have the forces between these two charges to be same as what it was in the medium. Okay, now let's move on to the next question, which says that there are three charges plus q, q and plus q that are placed respectively at distance 0, d by 2 and d from the origin on the x-axis. If the net force experienced by the plus q charge, which is at x is equal to 0, is 0, then what is the value of small q in terms of capital Q? So let us first draw the given condition. So we have the x-axis at x is equal to 0, that is the origin. We have a charge plus q, and at a distance d by 2 from the origin we have a charge q, and again at a distance d from the origin we have a charge plus q. So we are also telling that the net force which is acting on this charge plus q at origin is going to be 0. That means the force on this charge at x is equal to 0 due to the charge at x is equal to d by 2, and the force on this charge plus q at x is equal to 0 due to the force on the charge plus q, which is at distance d, is going to be 0. That is plus f q is going to be 0. So this can be written as f capital Q small q is equal to minus of f capital Q capital Q. So this implies k q by d by 2 ka whole square is going to be equal to minus of k q square by d square. So by simplifying this, we will get q by 1 by 4 equal to minus capital Q. So my small q in terms of capital Q will be minus q by 4. This is the solution. Now the next question has a bob of a simple pendulum of mass 2 grams and a charge of 5 microcoulomb. It is at rest in uniform horizontal electric field of intensity 2000 volt per meter. At equilibrium, the angle that pendulum makes with the vertical is. So we are having a pendulum like this. Okay, we are having a pendulum of with a bob of mass m and q. Okay, now this is not at rest. Okay, it's now when I'm applying an electric field, it is going to move to this position. Okay, now at this position it is at rest. Okay, so this means what are the forces which is acting over here? The tension, the electrostatic force, and then the gravitational force. So let us consider that bob as a small point. This be the theta. Okay, now this will be my electrostatic force and this will be my gravitational force and this will be my tension. Now resolving the components of tension into two, we will have this as our t cos theta and this as our t sin theta. Because theta is here, because when you drew the normal, theta will be here, so the same theta. Okay, so from this diagram we understand t cos theta will be equal to the gravitational force, t sin theta will be equal to the electrostatic force. Now dividing these two equations, we will have tan theta to be Fe by Fg, so that is mg by, that will be Qe by mg. So my theta is going to be tan inverse of Qe by mg. Actually this is a general formula which can be used for all the numericals which is of this model. So here the charge is given as 5 into 10 to the power minus 6 coulomb and the electric field is 2000 volt per meter. Then the mass is 2 grams and the acceleration due to gravity is taken as 10 meter per second square. So by simplifying this, I will have my theta to be tan inverse of 0.5. Next question. Two fixed charges plus 4q and plus q are at a distance 3 meter apart. At what point between the charges a third charge plus q must be placed to keep them in equilibrium? So they are telling that I have a charge plus 4q and another charge plus q and they are at a distance 3 meter away from each other. So they are 3 meters away from each other and I am going to place another charge plus q in between them such that they will be in equilibrium. So let's say this distance from 4q will be x and this distance will be 3 minus x. Okay, since they are in equilibrium, it means the force on the charge plus q due to the charge plus 4q is going to be equal to the force on the charge plus q due to plus q. So this can be written as, I will write it like this, is going to be equal to the force on charge plus q due to plus q. Okay, that is k 4q into q divided by x square is going to be equal to k q square by 3 minus x the whole square. Now this will be 4 into 3 minus x whole square is equal to x square By simplifying this, we will have 9 plus x square minus 6x to be equal to x square. By simplifying this, we will have 4x square minus x square minus 24x plus 36 is equal to 0. That is 3x square minus 24x plus 36 equal to 0. This is x square minus 8x plus 12 equal to 0. So my x is supposed to be this is 8 plus minus 4 by 2, that is 6 or 2. So if my x is going to be 6 meters, it is not valid, right? Because the entire distance between the plus 4q and plus q at the extreme itself is 3 meters. So my x cannot be 6 meters. This is wrong. So my x is supposed to be 2 meters and my 3 minus x is supposed to be 1 meter. So the arrangement is such that plus 4q plus q plus q. So the distance from this to this is 2 meters and the distance from this to this is 1 meter. Okay. Now, there are 3 charges that are kept at the corners of an equilateral triangle and another charge q is kept at its center. The ratio of the small q and capital Q so that the system is in equilibrium. So, we are having an equilateral triangle. Yeah. So we are having an equilateral triangle like this and there are plus q charges at the corners and this side is L and we are having another charge plus q at the center. Now let us consider this charge plus q. Okay, they are telling the system is in equilibrium, right? So the force, okay, we also name it so that it will be easier to understand. Let's say this point is A, this point is B and this point is C and this point be O. Okay, then the charge on the charge Q at point A experience a net force of 0, right? So that is the force on charge Q at point A due to the Q at point B. I will write it as FAB and FAC plus FAO should be equal to 0, right? So So this is going to be my FAB and this is going to be my FAC. And we know that the angle in equilateral triangle is 60 degree. So this will also be 60 degrees. And there is another point O over here. So because of this, the force will be of this direction FAO. Okay. Now let us write what FAB is. FAB will be simply KQ square by L square. Similarly, my FAC will also be KQ square by L square. And we have seen that the angle between these two forces is 60 degree. So the resultant due to these two will be, let's say F1 will be root of FAB square plus FAC square plus 2 times FAB FAC cos of 60 degrees. So this will be 2 times kq square by L square का whole square plus 2 times kq square by L square का whole square into 1 by 2. So this will be root 3 times of kq square by L square. So this is my net force due to the forces FAC and FAB. Now I need to find what is the force FAO. So for that I need to know the distance between point A and point O, right? So I will draw that along. So this will be angle 30 degree because the equilateral triangle, this entire angle is 60, and I'm connecting this point to the center, so this angle is supposed to be 30 degrees, and I know the entire length of this triangle is L, so till this it's going to be L by 2. So from this I can write, let's call this as D. From this I can write my cos 30 degree as L by 2 by OD, sorry, L by 2 by OA. So the OA we need is just L by 2 by cos 30 degrees. Cos 30 is root 3 by 2. So my OA is simply L by root 3. Now the force FAO will be KQ into small q by L by root 3 ka whole square, which will be 3KQQ by L square. Now we have seen that the system is in equilibrium. This means this resultant force F1 due to FAC and FAB should be equal to the force FAO, right? So my F resultant is root 3 KQ square by L square. So this is going to be equal to this. Root 3 KQ square by L square is equal to, or the net force, right? So the sum of these is equal to 0. This implies root 3 q is equal to minus 3q, or q, the small q which we wanted to find is simply minus root 3 by minus 1 by root 3. So the ratio between small q to capital Q is 1 by root 3. So the answer is 1 minus 1 is to root 3. Thank you for watching this video.